Next, we have the property that we haven't explained yet. Here is the one called Approximate 2, of course, Approximate 2. If this is set to 0, we find that the rebar we are placing, if we go here, for example, and start placing the rebar like this, here we'll find that it achieves the overlap value for me. Let's close the second rebar. Okay, now if we look at the difference between the two rebars, it will have achieved the overlap value for me, but it hasn't achieved. Meaning, if we look and select the rebar, we'll find that the rebar is placed with a length of 3,140. And if we look at the second rebar, we'll find it's placed with a length of, say, 5,700. For example, this first rebar has a number that is not the exact number or is not a correct number. No one works with a number like that. So I'll need to adjust the length of the rebar later, either by changing this length here or by correcting it in straight length or by any of the methods we've already explained. Of course, this will change the value of the overlap. So I'll need to adjust my distances again, and it will start to affect all the rebars that come after that. That's why we can set the value of the rebar to approximately the number I want or round it to a specific number. For example, I want to tell it to round to the nearest 100 millimeters. So this means that if we set this default, any rebar I start to place will be rounded to the nearest 100 millimeters. So if we place this rebar like this and so on and so on and so on, we finish. Now let's select any of the rebars we have, or if we want to add label of them, we select them all to see their lengths. Let's take a look at the lengths. All the lengths are rounded to the hundreds. All the lengths are rounded to 100 millimeters. 5,300, 5,300, 3,200. So all the lengths are rounded to the hundreds. It fulfilled the condition of rounding to the nearest 100 millimeters. So if you want to round to the nearest 2 millimeters, 50 millimeters, or whatever number you choose, say, the nearest 70 millimeter sit will start rounding all these lengths to the number you've selected. This is the main benefit and clear advantage of using the Approximate 2 command. And as we saw earlier, we had made it from set as default and saved it together. And of course, this number is applied and also works with our overlap value. So for example, if we select this rebar and move it up to calculate the overlap distance, we'll find that the lap length here is also in thousands. Let's do that. And if we check hours dimension, we'll also find that it's become 1,000. So the matter doesn't affect the overlap values at all. Taking into account that only the last rebar has an overlap value that's a bit larger than the other rebars, and we'll see what's happening with the last rebar. Of course, as we've seen, all the overlaps we have are set to the value of 1,000 that we entered, the last rebar, in order to achieve the final side cover and also reach the actual length I want, for example, rounded to the nearest 100 millimeters, for instance. So it needs to push the overlap value a bit in order to achieve those numbers. So if we look at the overlap of the last rebar, we won't find it to be 1,000. Instead, we'll find it to be a little over 1,000. If we look here, it's coming out as 146. The number is coming out as 146. And the reason for this, as we said, is so it can achieve the minimum overlap value I need, which is 10. And at the same time, the remaining distance that was calculated here was added to the rebar length to satisfy both conditions that I want. The side cover condition is that if we look here at the covers, the side end cover needs to be 50, meaning this distance should be 50. And at the same time, it fulfills the condition that the rebar length should be a number rounded to the nearest 100 millimeters. So it actually gave me 5,300, and at the same time, it doesn't create an overlap less than 1,000 millimeters, which is what was done here, for example. Therefore, all my overlaps are coming out as full lengths, except for the last one, which comes out as a full length plus a fraction in order to meet my conditions.